So the next topic we're going to look at is rich domain models and how we make them. So it's again about the domain model that we talk about, not about the technical classes, or the domain classes. So what we talked about yesterday with this controller, where all the logic is in the controller, we call that an anemic domain model. The idea is that the domain classes, they don't have business logic. So here the order, it has attributes, date, customer, amount, and getters and setters for them. But no business logic, no methods, check out the order or any other methods. And all the methods are here they call it a service, an order service or an order controller. Register order, close order, check order, update availability. All the logic on an order is in this order service. This is plain procedural programming. This is methods working on data structures. You use object orientation, only you have classes or objects and they are plain data structures. Now we want rich classes, rich domain classes. So the disadvantage of such a model is that first of all, you don't use the powerful OO techniques to organize complex logic. The encapsulation and the polymorphic behavior and all these kind of things. Well, business rules are hard to find, understand, reuse and modify. Well, you might think, well, they're actually easy to understand because they are in one place. That's true. Only when it becomes bigger, your application becomes bigger, then these controllers become so complex, it's difficult to find the business rules. And often there's also repetition, that is copy-paste code, what you often have. So the software reflects the data structure of the business, but not behavioral organization. The behavior of the business. So you have basically your classes are data structures. And you can model the structure of the business, but you also want to model the behavior of the business. What are the business rules for an order? What are the business rules for a payment? And here these service classes, they become too complex. No single responsibility, no separation of concern. It's all in one class. So that's not what we want. What we do want is a rich domain model, where we have a very small service. That's now the service we looked at. It's a facade, as small as possible, no business rules, and rich domain classes. And that's what we're going to look at here. So for example, a line item there's an order that has line items, which has the method calculate amount. We have a money class, which has a currency and an amount, and you can add money and you can subtract money from it. That's logic in the money class. So that's what we're going to look at now. What are the techniques to create a rich domain model? And they come from domain-driven design. We have in our domain, we have entities, value objects, domain services, and domain events. So up to now, what we have seen, we found the objects and the classes in the domain. But we can make a distinction there. We can even make it better. This gives better guidelines of finding domain classes. First, we have entities. What are entities? Entities are the classes that have identity. Something that makes them unique. So an order has an order number. That's the identity of an order. A customer typically have a customer number. It's the identity for the customer. A car as a license plate. It might be the identity for a car. So to see some examples, a customer with a customer ID, a package with a tracking number, a product with a product number. These are entities. So another characteristic of an entity is its state may change, but the identity always remains the same. So the package always has the same tracking number. Customer always has the same customer ID. Product always has the same product number. But the price of the product might change. The phone number of a customer might change. That's the idea of an entity. So the state may change. So it has a sort of a life cycle. The order first is placed. That's state. Then it is paid. Then it is fulfilled. Typically the state diagram. That's an entity. It has identity that remains the same. It has a sort of a life cycle. The state may change. The phone number of a customer might change. The state of an order might change. That's an entity. So here we have an entity called, it's a customer here, and ID is 1, that's the identity, and the name is Steve Smith, the Twitter account, and the favorite color is blue. At a certain point in time, even it is not Steve, but it is Stephen. So he changed his name, or we correct his name. And then at a certain moment later in time, he changed his favorite color from blue to orange. That can happen with an identity, but the identity remains the same. The next one is a value object. So what's a value object? It's an object without identity. Let's look at an example here. An address. An address doesn't have something unique. What makes this address unique? Well, it's zip, street, city, zip together. If I have two addresses and they're street, city, zip, there's a difference between them, then they are different addresses. If they are the same, then that makes them equal. But there is no address number, address ID, and those kind of things. Like a review. You place a review on a product. There's so many stars and this is the description. That's a value object. Doesn't have a review number or something like that. Money. So here you see money, weight, dimension. With those kind of things, typically we have a number, in this case the amount, and the currency for money. The dimension has a length, a width, and a height. A weight has a value and a unit. It's so many pounds, so many kilogram, so many gram. Money can be dollar currency, can be euro or rupee or whatever. Another value object would be an order line or an item line in a shopping cart. That an order has identity and it has a list of order lines. An order line doesn't have an identity. An order line cannot exist without an identity. So typically these classes, they typically don't exist as an object without an entity. So a customer has an address. A product has a number of reviews. A package has a weight and a dimension. An order, the price is a money class. So a value object belongs to an entity object. So the idea, it doesn't have identity. If we want to see if two value objects are the same, we look at their values. An important characteristic of a value object is you want to, or you need to, you should make them immutable. What's an immutable class? or an immutable object. An immutable object cannot change its state. It always has the same state. If you need new state, you create a new instance. So it doesn't have it doesn't have setters. It doesn't have mutator methods. Methods that change the state. You don't want that in value objects. Why? So also we'll comment that, but an immutable class you never have any problem with. With mutable classes you can have all kind of problems. So there are a lot of characteristics for a value object. First one, no identity. So a weight, no identity. A length, no identity. A review, a location, no identity. So an entity has identity. A product has a product number. A person has a customer number. So for database access, a value object might have an ID, but that ID has no meaning, no value in the domain. If I give weight an ID, because I have a weight table or whatever in the database, and I want a primary key and I call it ID, that's fine. But it has no meaning in the domain for a person with a weight and a length, or a package with a weight and dimension or whatever. So, no identity in the domain. That's an important one. Second one, attribute-based equality. So if I have two address objects, they are the same if the attributes are the same. If I have two money objects, they are the same if the attributes are the same. That's different than an entity. Then, behavior rich. Value objects do have methods. Sometimes they don't have, but you want to give them methods. So here I have a meters class, and it has a value, it's a long here, 3 meters. What kind of methods does it have? 2 yards. So it returns the long of this meter class, 3 meters, but now what it returns is, how many yards is that? Or how many kilometers is that? That's what this method returns. Is longer than, and I provide another meters class. So I have a meters class, 3 meter, and 3, it's a long, and 4 meters. And I say, is this one longer than that one? So I call is longer than, and then I get an answer true or false. Or is shorter than. So it has methods and logic. Meters logic. Cohesive. They belong together. So money, amount of, and currency belong together. If you just say, well, it's 100, 100 of what? Dollars, rupees. If you say color, so in a color, I have here red, green and blue. That defines my color. It's something that belongs together. And then here also you see methods equals. So I can compare, are 2 colors equal? Here also equals, are 2 money objects equal? I can add money objects. So basically what I can do, here is the logic to add $100 and 5,000 rupees. Because one money object is 5,000 rupees, one is $100 and I can add them together. Then immutable. The state cannot change. How do you make an immutable class? First of all, you don't have setters. There are no setters. You set the state in a constructor. In this case, money has a value. You set the state in a constructor. If I would have address, in a constructor you set street, city, zip. But there's no setter. There are getters, that's okay, you can get the value. There are no setters. There are no mutators, methods that change the state. If you want to change the state, so I have here an add method. I want to add some money class, money object to this money object, or I want to subtract money from this money object. Now, what you see here is that this add method returns a money class. So what it does, it doesn't change the value of this money instance, no. It returns a new money class, a new money instance, I should say. That's characteristic of an immutable class, that whenever you ask something that should change something, then you get a new instance. You give everybody a new instance. That's the nice thing of an immutable class. Like a string in Java is an immutable class. If you do string concatenation, you get a new instance. Why would we want this, an immutable class? Well, for example, they are thread safe. Instead of having one instance and you share it with multiple threads, then you have to make sure that class is thread safe, otherwise you run in all kind of synchronization issues. That the first one with thread scheduling, it depends on how the thread scheduling is that decides what the end result will be. So typically a lot of server applications, server-side applications are multi-threaded. So with mutability, you never have any problem. Everybody gets its own object. Just do with the object what you want, somebody else has its own object. So it's very hard to make mistakes with it. It's easy to share, everybody gets a new copy. You can combine these mutable classes and then you get a new mutable. That's basically what I do here. I combine two money objects and I return a third one, a new one. They're easy to test. So whenever you can make an immutable class, make an immutable class. It's just best practice for coding. But entity classes cannot be immutable because they have an identity and a state might change. Well, in that case, you always try to minimize mutability. Only those things that you can change have setters or mutator methods. The other ones you make still immutable. But value objects are always immutable. Combinable, so that's the thing here. Here I combine two money instances. I add two weights. I have in a shipment I have 3 packages. They all have their own weight value object. I add them all up together. I combine them. Self-validating. It's also typically something you do in a value object. So in this case I have money, which is here a big decimal, and in my domain that money is not allowed to be smaller than 0. It's not allowed to be negative. So what I do in my constructor, when I set a value, I say validate value, and what it does is if it is smaller than 0, throw a money cannot be negative value exception. So this kind of validation you also want in your value objects. And then testable. If a class is immutable, cohesive, combinable, then it's typically also easy to test. These are very powerful objects, value objects. So when do I use them? Different use cases here, but first one, describing a descriptive, first thing. identityless concept. So I have a bank account with all the stuff of a bank account, but there is money in there. And I can specify here what's the currency. So it's identityless, money is identityless, but it is descriptive. Or I have an order and it has a shipping address. The shipping address is a value object. It is descriptive, street, city, zip, it belongs together. It's identityless, but it belongs to the order. It's the shipping address. And it enhances explicitness. So here I have a shape, and the shape has a color. Now what I can do here is, I have a string color code. Well, always when you have a string, think twice. A string is actually not a good type to use. Sometimes, yeah, you have a first name, a last name, that's a string. But color code, basically, so the problem is if I make it a string, I have to pass that string. What does it mean? There are typically numbers in there, maybe red, green, and blue. So what's the color code? What is the allowed range? I don't know. What is the structure of the string? I don't know. And it's easy to make mistakes with that. So I make a value object of it. I have a value object color. It has the attributes red, green, and blue. And it has behavior. Add color, add red, add green, add blue. So it's clearer. It's easier to understand. It has built-in validation of what is allowed. And I put that in a color value object. Very powerful, these value objects. Instead of just having a string with some color code into it. It's easy to make mistakes. This is much better. What you also can do is, we will look at, or actually, you learned it in ASD, factory methods. But what's a factory method? It's a method that returns objects. It creates objects and returns them. Like a factory in real life makes things. So a factory method makes objects. So here I have a height value object. And it has a measure, unit, meter, feet, or yard. And so it has a value, which is an integer, and a measure unit. So maybe a height can be 3 feet, 6 yards, 10 meter. In the constructor, I set the value in the measure unit. But then I add factory methods. I say from feet with a certain value. So basically you say here, give me a height object from 10 feet. So here, give me a height object from 10 meter. So the value and then the meter. So we call them factory methods, methods that create objects. So you can also add them, and typically they are static. So I can just say height, my height is, and then static capital height dot from feet 10. And I have a height object. It's very easy now to instantiate height objects, value objects. Now, you want to be as explicit as possible. So here I say I have a customer that has a list of phone numbers. That's not very clear. So, okay, the first phone number. What's this phone number? The home phone, the mobile, the work, it's a private number, whatever. Well, it's better to do it like this. A customer has three phone numbers. A home number, a mobile number, a work number. It's more expressive, it's more clear. Similar, we can have multiple addresses. An order can have multiple addresses. A shipping address and a billing address. You don't create a list of 2 addresses. No, Say one is shipping, one is billing. Now, if you know already databases, now I have these entity objects and I have value objects. If I store, so we saw the technical classes that go to the database, data access objects or repositories. You have a data access object for every entity object. So, but only for entity objects, not for value objects. Now let me give an example here. So I have an order. This is the order. And the order has a list of order lines. With the quantity. And you want to save this order in the database. So you do have an order data access object. It's the order DEO. With save order, update order, delete order, find order. But you don't have an order line data access object. So this is the entity. This is the value object. Typically value objects, we don't have a data access object for it. Because this order line cannot exist without an order. It doesn't have a meaning without an order. So it really belongs to an order. In this case we have multiple, we have a list. So if you save or update the entity in the database, then you also update or save the value objects in the database. If you retrieve an order from the database, it contains already all the value objects in it. Similar with, I have a customer, that's my entity, and I want to know its address. Actually, we could have more value objects. So we have an address and we have contact details. This customer has contact details, email, WhatsApp, Facebook, phone numbers. These two are both value objects. So I only have a customer DEO. So that doesn't mean there is no address table or that there's no order line table or contact table. That's fine. But there is no data access object for it. You always work with entities if you go to the database. Save this customer, retrieve this customer, and then you retrieve also its address and contact details. Update this customer. If you want to change an address of a customer, you retrieve the customer from the database, you change the address, and you update the customer in the database. And that will update the address. And then, I'm not going into too much detail, but you have different types of databases. In a relational database, you typically do normalization, and typically these value objects often have their own table. And with a NoSQL database like Redis, Cassandra, Mongo, typically you store these value objects as embedded, and then we don't talk about tables anymore, so it probably is a document, but you store the item lines in the order. You store the address in the customer. That's typically what you do in these kind of databases. Now, let's say I go to a sports game, a soccer game, or American football or whatever. And I have a ticket, and on a ticket it doesn't have a seat number. So I can sit wherever I want. Is this ticket, or this seat basically, is it a value object or an entity object? Well, it's a value object. It doesn't have identity, it doesn't have a seat number. You can sit wherever you want. But if I buy a ticket with a seat number on it, then this seat is an entity object. It has identity. I am in seat 315. That's my seat. So if something is a value object or an entity object, that depends on your application. What kind of application do you have? So if I have a customer application that deals with customers, and I want to know the address for every customer, then the address is a value object for the entity customer. If I have an address book application, then address is an entity, because I have addresses and I update addresses, I add addresses, I retrieve addresses, I change addresses, then it's an entity. So it's not always clear if it's an entity or a value object. Typically we say, if you doubt, make it a value object, till you find out it should be an entity object. But it's important that you know the difference, entity or value object. If it has an identity, it should be an entity. Otherwise, make it a value object. And then what we could do, and this is often what you see in real life projects, but you don't want this. I have a customer, which is an entity, and it has everything from a customer. Customer number, first name, last name, email, phone, street, city, zip, state, country, username, password, with all the corresponding logic. So validate email, validate phone, validate address, validate login, check username and password, compute distance. Lot of logic, all in the one customer class. Well, that's not single responsibility. This customer has a lot of different responsibilities about login, about addresses, about contact details, about address details. So what you do, you try to make the entity as small as possible and put as much data, attributes that belong together in a value object. So now the customer has an address, street, city, zip, state, country. And it has its own validate method that validates an address. Here I had a validate address method. Now it's nicely encapsulated in the address, and there are all the attributes. Compute distance. I want to compute the distance between two addresses. Well, that logic should never go in a customer. The customer computes the distance between two addresses. Why? Because we have address information in the customer. Now, we make it special value object address. Similar contact. We have email, phone in this case, but we could also have Facebook URL, WhatsApp number, all kind of other contact details, emergency phone number, and we have a validate method for that. Here, login, username, password, that belongs together. I call it login with a validate and a check. So the check checks if the username password is correct, yes or no. So you don't want these big entities. No, you want small entities with value objects as much as possible. And then these value objects, they have all these powerful characteristics. They are immutable. It's always, never can go wrong with that. They are self-validating. They are self-descriptive. They have methods, so they are rich logic. You can combine them. All the characteristics that we've seen are in these value objects. So now, yesterday, the day before, we looked at making domain models. This is the way you should make domain models. So we are in the domain layer. These are not technical classes. I'm talking about the domain. So characteristics here, entities have identity. Values objects don't have identity. Then when are two objects the same? Well, two entities have the same ID, then they are the same. Two value objects is the data. If the attributes are the same, then they refer to the same object. Entities have history, a lifespan, so I can change my email over time. Value objects, 0 lifespan, meaning they can never change. If you want to change them, you just create a new object. A value object should always belong to one or several entities. Cannot live by its own. What does an address on its own mean if it's not an address book application? What does a review on a book mean without having the book? Okay, I have a review, 5 stars, great book. What do I do with it? Well, it belongs to a book. I have an order line. I have three TVs. Yeah, but it belongs to an order. So it can't live by its own. And then value objects should be immutable. Entities are mostly mutable. So if you change the value object, create a new one, instantiate a new one. Value objects don't need their own tables, but might. It's okay. But it can also be embedded data. If you doubt, prefer an entity object. They are much richer, much safer, much more expressive, but you always need entity objects to connect them to. Okay, now we have entity objects, value objects. Introduce another one, a domain service. So that's different than the service we've seen so far. Let me first give an example here. I have a shipping cost calculator. It has a method compute shipping cost, but the algorithm to compute the shipping cost is based on the package, the address, the shipping address, and let's say the type of customer. We have maybe VIP customers that pay less for shipping or don't have free shipping, for example. So the algorithm of computing the total cost depends on attributes in the package, the weight, maybe the size, the address, what's the distance, and maybe if it is an international address, then it also has influence on the cost, and the type of customer. So in this case, the package is an entity, the address is a value object, and the customer is also an entity. So I need a method that has to deal with data of different classes. So what did we learn in object orientation? Put the method in that class where the data is to implement that method. So if I have a shopping cart and I want to compute the total price, then that should go into the shopping cart, because the shopping cart has all the order lines and the products, and it can compute the total price. But now I have a method compute shipping cost. I could put it in the package, But then I have coupling to address and customer. I could put it in the address, but then I have coupling to two other entities, package and customer. I can put it in the customer, but that doesn't fit there because then I have coupling with the address and the package. So what do? I make it separate class, a domain service. Now, this domain service lives, that's why we call it a domain service and not a service, to avoid confusion. So, again, going back to my layering, here's my web layer. Here's my service layer. Here's my domain layer or data access. And, domain or business logic. Here's my data access layer, and here's my integration layer. So, technical classes, I make them in blue, they live here. These are the plumbing classes. So, these services are, you could call them technical services, but we call them services. That's how everybody calls them, so we also call them the service class. It's the facade, the reception where you enter. But now, I have a package class. This is my package. I have an address class. And I have a customer class. And I need attributes for all three of them to compute shipping cost. What do I do now? I create a domain service. That's why I put a domain in front of the name service. A domain service lives in the domain. It contains business logic. Computing the shipping cost is business logic. And it will talk, it talks to the package, the address, and the customer. And then it can compute the shipping cost. That's a domain service. So what are the characteristics? A domain service has attributes that get in, and it returns something. The methods get arguments, and they return something. So you see that here, compute shipping cost, there's a package, an address, and a customer that go in, and it returns the cost. You see that also. This is what goes in, maybe two entities and a value object, and there's a result that comes back. That's typically how methods on a domain service look like. And that makes that a domain service is always stateless, doesn't have attributes. The state is in the package, the address, and the customer. The domain service is just do this, and this goes in, this comes out, and then they're done. It has no behavior. There's no identity. There is no shipping cost calculator ID. There is no shipping cost calculator table in the database because it doesn't have attributes. So it's a method, it's a class that has methods. What are the characteristics of these methods? They need data from multiple classes, mostly entities, to do something. Here my service method needs attributes from class B, C, and D, and then returns something. So typically this service method, or here the compute shipping cost, is a static method. You don't have to instantiate the shipping cost calculator. No, you just say shipping cost calculator.compute shipping cost. You don't have to instantiate because you don't have attributes. It's a stateless class. That's a domain service. It's sort of an orchestrator, so we talked about orchestration, but it is small. It's the scope is small. The scope is just between the package, the shipping address, and the customer. Then that orchestrator is okay. Now coming back to controller. If you say, well, this is a controller, and you do it like this, then it's good. But then don't call it a controller, call it a domain service. Call it maybe shipping cost calculator domain service, that's fine. It's a domain service. A controller tries to do everything. So for example, the address, we need to compute the distance between our address, where our warehouse is, and the shipping address. This compute shipping cost, or this class and this method, will not compute that distance. So what will a controller do? A controller will ask the shipping address, give me your street, give me your zip, give me your city, give me your country, and then compute. What does a domain service do? It asks the shipping address, compute the distance between you and this address that I provide. So the business logic of computing the distance is in the address, not in the shipping cost calculator. That's the difference between what we normally call a controller and in this case a domain service. Maybe that customer has a certain, how do we call it? A certain reference. Let's call it a reference. I don't know how we would call it. A reference, which is a string. And depending on that string, that decides what the shipping cost is. So if you're VIP and you as a customer are older than 50 and you do have a WhatsApp account, then the reference is this. Let's call it A. But if you're not a VIP and you're younger than 30, then your reference is B. And if you're younger than 20, your reference is C. Now this is logic, business logic. So that's all built in the customer with the method compute or get your reference. So this is not a controller, it's a domain service. Here's another example. I have an account, and an account has deposit, withdraw, those kind of things. Compute balance. That's all logic for the account. And why is it in the account class? Because it deals with all the account entries. If I want to compute the balance, then I add up all the amounts in my account entries. If I want to deposit, I create a new account entry and add it to the list. But there's also a method transfer funds. Transfer this amount to this account. So we have two account instances, the from account and the to account. I call the from account and I say transfer funds. So let's draw, oh sorry, I didn't go back. I was here in the slides. I didn't go back. Let's go back here. So I have two accounts, account 1 and account 2. Now, in my example, the account has a transfer funds. So let's say the top one is the from account. So I say here, transfer funds $100 to account, that's to account 2. This is the method. So what does account 1 do? Account 1 does a withdraw by itself, withdraw $100, and it does a deposit of $100 by account 2. Now this looks pretty much okay. But now I'm going to add business rules. You're not allowed to transfer money if the amount is bigger than 1,000 and you transfer the to account is a saving account. That could be a business rule. So this business rule will go into the transfer fund method. So what kind of account you have and what is allowed is in every account. So let's say this account has also a type here, an attribute type, which is just a string. I'm a checking account, I'm a saving account, I'm a business account, I'm a children account. And then there's another business rule. You are not allowed to transfer funds from a children account to another account if that other account is not an account within that family. So children are not allowed to transfer funds. They are only allowed to transfer funds within the family, to the parents and the brothers and sisters, just for safety. Well, that's a business rule in the transfer funds. Now let's add another business rule. If your account is a checking account and it is Tuesday, you're not allowed to transfer funds. I'm just making up all kind of business rules. But you get the idea. I make all kind of business rules, but they depend on the type of account you have, or how much money is in your account, or how much money you want to transfer. And I can make up all kind of other things. What day of the week is it? All kind of things. Well, you don't want to put all that logic in the transfer fund method of an account, because there's so many other things that it depends on. Now you want to extract that and put it in another class. You make an transfer fund service that contains all the logic for transfer funds, but transfer funds only. So it has one method here, transfer funds, the to account, the from account, the amount, and a description. And it contains all the business logic. What is allowed, what is not allowed. Maybe if you transfer funds from your saving account, from your checking account to your saving account, you get, for every $1,000, you get $1 extra. It's a bonus because you save. You don't want to put that all in your account. Now there's a separate class, because what goes in, there's basically two accounts, a from account and a to account. And based on the type of the accounts, the day of the week, the amounts, all these things, it's decided how it should work. So that's an example where you want to use a domain service. You don't want to put that in the entity account. If it's super simple, you could put it in the entity account, but typically there's all kind of different logic. Then you put it in a domain service. Okay, so now we have three classes. Entity, value object, domain service. So one last class we have to look at, domain events. So again, it's not just an event. It's not a send email event. No, it's a domain event, an event that has meaning to the business, to the domain. A delivery failed event, where we cannot deliver. An order received event, the order is received now. These are domain events because they have meaning in the business. And they have typically they have attributes, and these attributes belong together. The delivery field events should know the sender, the receiver, and the message. The order received should know the order number, and maybe the customer number or the address where it is received. So we create a class for that. That's the fourth class. Next to entity, value, object, domain service, we have event classes. And they can contain logic, and they have attributes. They have a meaning in a domain. So they should come up in a domain. We should see them in a domain. Remember, domain-driven design, we want to make that the domain looks exactly the same as the business. No translation. Well, in the business there are events, so they also should be classes, event classes in your domain. And these again are immutable. Domain events are also immutable, also value objects, but also domain events. Often you share events. In architecture, software architecture, we will learn about publish, subscribe. There's a publisher that publishes events. There's a subscriber that subscribes to events. And that's a very powerful pattern, basically. So here's an example. I have a shopping service that's in my service layer. It talks to a shopping cart. These are domain classes here. Shopping cart, cart line, product. And whenever I call add to cart on the shopping service, it generates a product added event. That's a business event, domain event. There's a product added event. And there's another service, a recommendation service, that wants to know if somebody puts something in their shopping cart, I am going to look for this product. People who bought this product are also interested in these and these products. And then we want to show that on the web page. So in this case, the shopping service publishes an event. And then the recommendation service subscribes to product added events and handles the event. So you see two services, shopping service and recommendation service, they talk to each other. One publishes events, one subscribes to events. Well, this is, if you talk about loose coupling, this is loose coupling. Because the shopping service doesn't know the recommendation service, the recommendation service doesn't know the shopping service. They just publish and subscribe to events. But that's not the idea. The idea is we have in our domain model, we also can have, it's not always that you have them, but you can have classes that are domain events. So we're going to do in the lab, we're going to do an exercise with this, but this helps you, these four classes, entities, value objects, domain service, and domain events, they help you to create a good domain model.